Hi, my name is Brendan Fleig-Goldstein, and I'm a postdoctoral research fellow in the Department of Philosophy and the Cogut Institute here at Brown. I work on the philosophical foundations of cognitive science and artificial intelligence, primarily as a philosopher of science. A central question I attempt to answer across a lot of my work is what counts as strong evidence in science? How have scientists historically attained strong evidence for their claims? And how can cognitive scientists in particular attain strong evidence for cognitive models? By cognitive models, I mean models of the information processing or the computations that occur in our minds that are not simply describable in purely physiological or behavioral terms. I'm particularly interested in how cognitive scientists can turn behavioral data into evidence for cognitive models. And even more specifically, I'm interested in how psychologists can use theories of rationality to turn behavioral data into evidence. Psychologists frequently and often implicitly utilize rationality assumptions when reasoning about evidence for how cognitive processes work under the hood. When you're studying a complicated black box, a sensible strategy is to try to break it in various ways to understand how it works. Eliciting mistakes is basically how psychologists can break the minds they are studying. For example, when participants are asked to assign probabilities to different possibilities, such as whether they think an insect they've never seen before is capable of stinging or not, humans make very characteristic errors. They're not just bad at the task, but bad in very consistent and predictable ways. These sorts of errors can indicate the kinds of algorithms that we might be using to compute these probabilities, and even more generally, reveal details about various cognitive parameters, biases, and inference strategies that we use. My work tries to understand why and how this approach works, and to think about how psychologists can systematically use errors to reason about cognitive processes. There's a lot of philosophical underpinning to think about in order to do this systematically. Mistakes are only mistakes relative to a standard of correctness, so this means psychologists need to utilize theories of rationality. And the question really is, what theory of rationality should they use? I've argued that if you use a theory of rationality, of ideal rationality, where rationality means perfectly conforming to, say, the laws of logic and probability, then mistakes are less informative. It's more helpful to use instead a theory of resource rationality. Resource rationality looks at the best you can do from a rationality standpoint given certain cognitive limitations, such as particular amounts of finite memory or attention. Thus, instead of one baseline where most of human behavior is just broadly suboptimal, you can make more fine-grained distinctions between a cognitive strategy being optimal relative to particular limitations of, say, memory, and a cognitive strategy being suboptimal relative to those same limitations. The idea is that those kinds of discrepancies better indicate new constraints that can then be incorporated into the account of resource rationality, which in turn uncovers new discrepancies between the resource rational standard and observed human behavior in an iterative process. The framework for rationality that I've developed also allows for the development of new concepts that have application to artificial intelligence. For example, once you're able to assess a system and determine that it's doing the best it can relative to its limitations, you can ask, if I increase or decrease its limitations in some way, will it continue to do its best? Just because a particular chess strategy, for example, works well if you can look 3 moves ahead, doesn't mean that strategy is optimal if you're now all of a sudden able to look 12 or 15 moves ahead. The capacity to maintain resource optimality as your circumstances of your constraints change is what I call a meta-reflective capacity. Maintaining resource optimality means you need to monitor or otherwise be sensitive to your constraints and alter your strategies accordingly. My current project argues that this cognitive capacity is the cognitive basis of what philosophers call a normative commitment, or a commitment to a norm. The idea is that to have a commitment to something, say an ethical principle, such as not being wasteful, it's not a matter of merely conforming to a rule. For one, you're allowed to make certain kinds of mistakes. But you need to try your best, come what may, even if things get harder for you. For example, in order to be committed to being environmentally friendly, if your town stops offering composting services, you should continue to find a way to compost. And if things get easier, you need to take advantage of the opportunity to do better. Normative commitments are important as they are central to many philosophical projects, such as ascribing moral or rational competence to a system in order to hold it accountable. But for AI systems, it's simply not clear how to identify commitments in a synthetic system. So my current project is trying to make progress on this issue by articulating empirically identifiable cognitive capacities, in this case what I'm calling meta-reflection, that can help us identify and potentially engineer commitments into AI systems.